Good afternoon and assalamu alaikum. Today we'll start the training. So I'm just sharing the slide. Then we'll go for full training. Mr. Nazim, can you mute? Thank you. This one. Oh, okay. Okay. I believe now it's okay. Okay. Again, today's topic is awareness of concrete strength and durability. Thank you very much for all attending. Sharfuddin, expert of backfilling, and hoping that next time Sharfuddin will take one session for backfilling. Mohammed Jafar Iqbal will take for all activities, site activities. Mr. Fauzi will take for site concrete. And yeah, everybody is very competent and expert, and everybody, and learning is a continuous process. Everybody. It's practical. Exactly. And Fauzi has very good experience in the ecom and full entire project handed over. So every activity he knows actually. Okay, I'm Rezaur Rahman, Senior Director Engineer at the Al-Handasah consultant. So I'll start the training now. Okay. Now changing. Okay, before starting the training, I want to state the quoting. So whenever we'll go to site or work, this is we have to think quality, safety, and sustainability. Not only the matching with the complying with the shop drawing and it is approved. No. So surrounding of this one, we must comply all other activities, all other requirements. First, quality quote. Quality is not an act, it is a habit. So can you share with me that what is quality? Very briefly. Thank you very much, Engineer Omar. We are talking about that no airy joint. So you are the first airy joint. Okay. And what is quality?
Construction term quality is doing the work procedure as per the approved method statement and the specification.
Okay.
Consent specification.
And as per the authority standard also.
Okay. Simply, if I tell you in one word, compliance.
Okay.
So if we can tell one project is with a high standard quality when it will be handed over with the compliance. So compliance with the requirement of specification, compliance with the authority, compliance with the So both are right. Okay. So simply when it will be compliance, that it will be. So what we can tell, quality is not to what is written in the specification, and we have to follow. Not like that. Quality should be our attitude. So it should be like habit. Not we follow that it is requirement of the specification. This should be as a habit. Second is safety. Whenever you'll go, safety is the first priority. Okay. Think that you have family, so you have to maintain your health and safety. Then you have to go for the activity. And third one, sustainability environmental. It is globally is very important and hot topic. So you have to ensure that we are not damaging the environment and sustainability. Okay. So go green, save your planet. Whenever you will go build your personal building, house, or out of the projects, so go for green and save the planet. Now I am coming to the next concrete. So the concrete main element of the concrete is the cement, right? And this is the concern. If you see that this lot of smoke is coming and damaging the environment. So now I want to highlight about the, first of all, I'm telling you this concrete is the awareness. So this is general awareness and what is our topic. It's not the what is all the requirement of yes. So if you have understanding about the concrete as a whole, then when you go to site or going to anywhere, you have better idea. So that's why I'm giving the clear some idea. If some contribution to your knowledge, it will be effective. So greenhouse, can you tell anybody what is greenhouse?
Greenhouse is actually normally we are using here in cement SRC,
Yeah.
surface resistant cements, which is making issue in the climate, you know.
Yeah.
And this it's kind of what you call this.
Okay. Yeah.
Greenhouse gases mean.
Yeah. Okay, I will explain. If you see that this is sun, from the sun, sunlight is coming to the ground. This is the ground. Okay. So ground is absorbing the heat, right? And then it is reflecting, emitting the heat to the again to the environment. But as there is some greenhouse gas means there is a carbon dioxide, okay, nitrogen dioxide, and a lot of chemicals. What is emitting to the environment? Even the water, the cloud. So after evaporation, what is coming up, right? This is also greenhouse. So what is greenhouse gas doing actually? As there is a greenhouse gas, this heat cannot go up. If you see the red one is coming back. Okay. So that means it is one time it is hitting the ground, and second time again after reflection is coming ground. So as it is absorbing the heat, total the mean temperature of the world is now 15 degrees centigrade. Okay, this is the livable. 15 degrees centigrade.
15 degrees.
Yeah, it is average of sea water
Uh-huh.
and soil water. It's some average last maybe 20 years. This now the what is the temperature? It is the environment friendly for the human being, plants, and animals. But if temperature is going 1 degree or 2 degrees centigrade up, water will come up. Yes, right? Right, Bangladesh and many countries will be underwater. You know, when temperature will be up, volume of water is expand, right?
Yeah.
So if temperature 1 degree, 2 degree, 3 degree, many plants will die. Many animals will die. Or many animals cannot survive. Even people, human being will not survive. So if temperature high, if it is down, this is also problem. So now it is a stable condition. That's why we are all afraid if carbon dioxide emission is more, then it will absorb more heat, okay? And the temperature will be higher and we cannot live, okay? Many plants will live. So this is the main actually greenhouse effect by sketch. Now I'm coming to the carbon dioxide. What carbon dioxide is emitting, this is the 76%. Total greenhouse effect, 76% is the carbon dioxide. Remaining 24% is other gases. Got it? If anything, clarification, you can ask. Okay. So the carbon dioxide, what is the source of carbon dioxide? Carbon dioxide is telling that, for example, everybody has vehicle, right? Vehicle. This petrol is basically carbon dioxide. Carbon dioxide. The power generation, electricity. Basically, we need energy, fuel, coal. So all are basically carbon dioxide, emitting carbon dioxide. Okay, that's why electrical car is encouraged. Elon Musk is started another electric car. Electric car is environmental friendly. Okay. So 76% carbon dioxide. That's why people are whole world is very concerned that to reduce the carbon dioxide. In UE actually 2050. Net zero. That means carbon dioxide emission should be zero. That's why we're encouraging electrical car. Although actually 2030, but it is impossible to reach to the year.
So 76% from cars.
Now 76% of the total greenhouse gas are carbon dioxide. That's the carbon dioxide is the main. Okay, Engineer Moore?
Yeah.
Okay, so this is mentioned that so where it is coming. Okay, I'm going very fast. Okay, now which countries are most emitting the carbon dioxide? China. China 32%. China. Most of the people, most dense people. Then United States 12%, India 7%, Russia 5%, Japan 3%. They're emitting carbon dioxide. Now this is a carbon dioxide because EU is a very small country, right? China is a big country, so China emission is big. Yeah. Now this is the per capita per person. Okay, per person, which is per person average is globally average 4.8. Qatar is the highest. See, Qatar is very small country, but they are using maybe 3-4 cars. Huh? Each family has 4 cars, maybe. Power generation and people is very less. So Qatar has 35.6. Okay. Bahrain has 26 point. That's most of the Middle East countries very high because every family has car. China maybe, India maybe, most of the family has no car. Okay, this is mentioned that who is sector-wise carbon dioxide emission, energy, electricity we're using. This is the 40% carbon dioxide emission. Transport, everybody is using the Jishan, you're using transport, right? So everybody is part of damaging the environment, everybody. That's why reduce the electricity. I prefer actually if I go out, it should switch off.
Use the number of
Yeah,
cars.
and water is basin coming, and should be very slow. And water generation, you need energy. That is our every activity is damaging the environment. Okay, Jose? Yeah.
Right.
You know what your intention?
Yeah, no.
Okay. Okay, now I'm coming to the concrete. Out of 100%.
What is the relation between this previous subject and the concrete?
Now I'm.
What is the durability?
And I'm coming. I'm coming. Now I'm going to the concrete. Concrete, if you see the below, 8% is out of 100% carbon dioxide. 8% are from cement. Okay, so 8% is cement. That's why we are concerned, and we are replacing the cement by other material. Okay. Okay, if you see the general configuration, the concrete, the aggregate we're using, almost 75%. Cement and water is 25%. Okay, now cement production. I'll go to the next phase. Cement production, you know what is the temperature in the used during cement production? 1450 degrees centigrade. When cement is production, produced, this total heat is used 1450. That means lot of coal requirement, a lot of energy required.
1450 centigrade.
Yes.
This is during the production of.
Yeah, exactly. That's a huge. It is damaging the concrete. Yeah. Okay. Okay, that's why we have to. We are here. It is recommended to replace cement by GGBS and others. Okay, so this is also
only this SRC. They are going to.
As same actually. OPC SRC same production.
OPC also they are going to.
Yeah, same. One for. Okay, now what is the replacement? Yeah. So you know we are using how many percent GGBS you are using normally? 65%, right? And 35% OPC.
Yeah.
Okay. So
Microsilica, GGBS, and gold adequacy certificate of 65%.
yeah,
The remaining chemical.
exactly. So why you are using GGBS?
Green concrete.
For the green concrete, right? So
Yeah.
because OPC is damaging the environment. And with damaging the environment, if you reduce OPC, then damaging environment will be protect the environment. GGBS as not damaging the environment. So not only GGBS, with GGBS we are using fly ash microsilica. In our project, microsilica 5%, right?
Yeah, sorry.
5% microsilica they used. Okay.
Not in all concrete. Somewhere this is 60.
Now we are adding specification over toll rate. No, 2020 that 21 toll rate, 65%.
Exactly. 65%. Some mixes at 65% GGBS
And
plus
microsilica, in which cases microsilica will be?
Microsilica using only
5%.
toll rate.
5%
Not
use.
that 5% we are using.
5%
But in what case?
40-20.
But it is I'll come actually. Yeah, The microsilica, I'll come to the point. Microsilica is very fine. Huh?
Yeah, yeah.
So between the aggregate, when you cast between the aggregate some gap. So microsilica is filling the gap.
Avoid voids.
Yeah.
Average, exactly.
Micro mean to cover the micro.
Stop, because
Exactly, micro.
what you want for the penetration for the steel.
Yeah.
To make it the concrete
Yeah.
softer during the placement and make it.
Yeah,
And
exactly.
It also
it's the
increase the
reinforcement.
durability and
It's the
decrease
reinforcement
viscosity.
also.
Reinforcement.
Microsilica as a reinforced.
It is
No.
Increase the durability.
20, 40, sir?
No, 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 no.
I think.
It is used with GGPS.
Yeah, yeah.
Yeah.
It's only on-
Microsilica is used here with GGPS
It's make
Yeah.
because it's very fine. Very
I know,
fine
I
and
know.
make it paste
Yes, yes.
and it is filling the small point.
Yes, yes.
Yeah, that's why concrete is here.
Yeah.
Normally, if you use only cement, there is a lot of voids, Okay,
Microsilica is only to fill the voids.
exactly.
Yes.
Yes.
Okay.
Okay, now I'll go very fast actually. So now GGPS. GGPS, you know how to produce GGPS? Anybody have idea? GGPS?
Steel.
Steel, huh? Yeah. See, steel factory. For example, reinforcement steel they are using production. When you are producing, it is like milk. There is a milk layer. Huh? When you get the milk, up top layer the milk, there is a what do you call actually? There is a layer, huh? Makana.
Butter. Yeah.
So when, for example, Ameris steel, when Ameris steel is going for production of the steel, the top layer, very few layer. This is GGBS actually.
This is GGBS.
Yeah.
So source of GGBS is coming from
Steel production. Yes.
Steel production.
Yes. That's why for the GGBS we are not producing separate. This is a byproduct of steel production. So if you use or no use, it will be a byproduct. Okay, that's why it is separately not damaging the concrete. Okay,
Can you share me this mix design?
yeah, I'll share it with you. Nasir, you can share it. Yeah,
No,
Sure.
yeah,
here. After that,
what next design you need will
Which
do.
one?
Will give the
Which one you need?
You want to see here on the screen?
But here this one.
Yes.
now mixed design. I did not.
Different, huh?
Yeah.
This is another.
Whatever you want,
Yeah.
he will give you later.
This is another university. Yeah?
This other
Okay, okay.
Okay, so now fly ash. Fly ash also same like GGBS. Fly ash is producing when power plant, when electricity generation. If you see, yeah, Ritesh, hopefully you will take the next session. Huh? Yeah. Okay, this when power plant, it is like a power plant. Huh? When you
Fly ash
use
is coming from the power plant.
power plant. Okay, so when you use coal, so it's the byproduct. Coal, the fly is the byproduct of coal. Wherever you use coal, byproducts. So that means no need to produce separately. No need to produce fly ash separately. Same like microsilica. Microsilica is a byproduct. Okay. Any industrial yet? So your microsilica
From where this production? How to-
production, yes. I forget it's not
Like
mentioned.
GGBS is from steel, so
Yeah.
microsilica from where? Oh,
Silica, I believe it's metal. This is also metal.
metal.
For the metal, it is here byproduct. It is used. Huh? So it is not separately production. Separate production. Okay? Now, if you see the strength, concrete strength. If top one is blue one is GGBS, right? GGBS. That means this is a strength, and this is the day. So if you use Portland cement or GGBS, this is a difference actually. Initially is going same, but ultimately GGBS concrete is getting higher strength. Okay, that's why you are selecting. Initially, it can delay. Okay. Now this is a heat of hydration. Concrete, when you mix the concrete, there's a heat production, right?
It's
You have idea?
reaction.
How heat is released or heat is
Yeah, when
produced?
cement mixed with the water, the chemical reaction will be.
Yeah.
So in this, the result, the heat.
The heat will occur at the same duration time mixing.
Okay, exactly. So here, if you see that when you cast any foundation, for example, encasement or whatever, so center red area is high temperature. It will be high temperature because it cannot release heat. But in the perimeter it is releasing to the air, right? Yeah, that's why perimeter area temperature is low and center area temperature is very high. So this area, it will be expand, right? Heat is more means it will expand. And this is heat is less means contract. That's why this crack is coming.
Cracks is happening.
Okay. This is the reason. Okay. So same it is mentioned here. And here, if you see the graph, so initially, quickly it is heat is very high. Then next 2 to 3 hours, it is like that. Then again, initial set. Anybody has idea about the initial setting time?
Yeah.
Initial setting
When
time,
water-
grade 3 over there.
No, when this cement make the chemical reaction with the water,
Mhm.
starting from chemical reaction, at that time is initial setting time.
Yeah.
When the concrete becomes set, this is 48
minute.
minute, I believe.
Yeah. So that means we'll consider when batching time. Batching plant, they are adding water to the cement. These is batching time. Batching time is mentioned in the delivery note. Always we are considering 2 hours from the batching time, not the any other time.
Yes.
So this is the initial setting time means when it loses plasticity, started to lose plasticity. Concrete is like like paste, right? Paste. So when it start losing,
Paste have become solid, starting to become solid shape.
yeah. When it is, you are
Yeah,
correct.
because this
When it is getting to harden,
the setting time is 48 hours.
Initial
Initial
45 minutes.
48.
Why not do
2 hours.
2 hours?
90
2 hours.
No. It's 48 hours.
No, engineer. The settlement
No.
time up to maximum 2 hours after that.
no. Initial setting time normally is based on the cement. Some are
45 minutes.
45 minutes. Yes.
45.
Yeah.
This initial.
But the final.
Final after 2 hours.
Check.
No, final some concrete is
As per the specification, it's
2 hours
90
means
minutes.
90 minutes, 2.5 hours.
Yes.
But not a 2 hours.
2 hours.
1.5 hours.
Yes.
Yeah, but the final setting time.
You know.
Actually, it is mentioned in the mix design.
For the pouring.
It is mentioned in the mix design.
He is right. You are asking for the settlement of concrete.
Best.
Two things. Within 2 hours, we have to use the concrete. This is one thing. A second thing is the final setting time means.
When we dish out of
Within 2 hours, it's mixing. Then mixing.
Yeah.
In the mixer, still
Don't worry.
mixing. After pouring, count 45 minutes.
That's when mine are-
Initial setting time.
Yes.
And final setting time is normally 6 to 7 hours. The final setting time, the when plasticity is completely gone and getting start to get strength.
Try to give you the evidence like.
This is hard.
I have maybe this specification or maybe
This is hard.
standard. This is
Mix
not-
it will get.
I will-
My mix it.
Maybe I'm wrong, but as per my knowledge, this is 48 hours.
Okay, so this is a graph is showing the strength. Yeah, heat is here. Initial setting time, and it is after few hours, it is final setting time, and it is going up and for years. It is more than years, it is heat generation going on. Okay, so these are basic reaction. You know that what is a component of cement? Anybody has idea? Component of cement. Okay, when cement and water you are mixing, it is showing cement water mixing. It is creating gel. Creating gel. This is actually calcium silicate hydrate. It is you are creating gel. This gel is responsible for strength. Why concrete is getting strength? Because of cement. And why cement is getting strength? Because of this gel. It is mentioned gel, right? Gel and it's gel. This gel is creating strength and producing heat. Okay. When you use GGBS, what is the difference between GGBS and here? When you use GGBS, it is slowing down. OPC is very
And
fast.
chemical reaction will be slow.
Yeah.
When we use
Yeah.
GGB.
Reduce the.
Yeah, exactly. So if you use OPC, it is very quickly it is here.
No.
And it is, yes, set is,
Yes.
initial setting time is first, final setting also first.
Yes.
If you use GDPS, initial setting time will be delay.
Yeah.
That's why if you use GDPS, contractor cannot remove the shutter because it is getting, getting time. This is the basic reason. This today's session is for the awareness of the basic things to understand. When you go to site, why then you will go to the
More
result.
strength and more resistance.
Exactly. So GGBS is slow down the reaction, and that's why that's initial setting time and final setting time will be delay. Okay. Flash of
Durability is also affect with GGBS and.
Yes.
exactly. So what I told you before that GGBS and fly ash using soft gel. Soft gel. This gel is filling the void between the aggregate. This is the main reason of the durability. If you fill the void, then what is salt? Why you're using GGBS? Because in the lot of chemicals cannot attack. If it is gap, chemical can very fast can reach and make the rust. Okay, this we already discussed. Yeah, these are microscopic photos.
So can you go back 1 minute?
This is a comparison actually. Yeah, Portland. I'll share the slides. Just try to read. So comparison Portland cement and GGPS. Portland cement, heat of hydration, temperature, risk of cracking, reaction time, strength. So this you can get.
Yes.
This is a microscopic photo that this after 35 minutes concrete is like that. After 3.5 hours it is like that. After 8 hours 10 minutes it is like that, and it is after 11.5 hours it is like that. This is another area. So this is showing that after 7 days, concrete is getting 70% strength. So that's why we are taking 7 days cubes, 70%. So always check. Nasir already knows, right?
Yeah.
Always go for crushing. You will see, but 7 days is indicative. Final test result will be based on 28 days result. Okay, now curing. Curing, there is a three condition. This cube is in the curing tank. Okay. This cube is at site condition with Hessian cloth. And this is a site curing, for example. Site curing. What do you think is which is the producing more strength initially?
This is a different condition. When you cube,
Yeah.
cube, we are normally this curing tank is better for it. But the
That's right.
column, this condition is more better than curing compound.
Yeah, no, but I am asking which is gaining strength. Strength,
Yeah, just during the outside condition, the cubes give us actual strength. But in the laboratory, this
No, why?
another.
No, actually, laboratory, same concrete we are taking in the curing tank.
But here in the site, this يعني.
If we are keeping the concrete in the tank, the side structure should be in the
Same thing.
not same thing.
Yeah,
Water should be same like this.
yes.
Okay, I'll come. There is a study that green is a site concreting. For example, site substation you concrete.
Okay.
This site concreting is gaining more strength initially because of the temperature.
Temperature maximum 30.
No, this is the environmental temperature.
Okay, temperature.
Because a site cube is a very small and it is releasing the heat. That's why concrete temperature is very less. When you cook, for cooking, you need to increase the temperature, right?
Yeah.
When it reaches to the certain temperature, then you can cook, right? Concrete is like that. Concrete temperature is more means more strength. But there is more reaction. More reaction means more generating heat and more
But
strength.
every particle with with ready with high temperature.
Yeah.
Will make restart.
Exactly.
Let's
So why site concreting is getting more strength because the area is volume is bigger, right? And center of the concrete cannot release the heat. For example, foundation. But small cubes, it can release
Temperature.
temperature and the actual temperature is very less.
Yeah.
Jose, am I right?
Yeah.
Yeah. So that's why initial temperature is very high. Concrete temperature is very high. And this is a site cube. Site cube is always less. And laboratory always 20 degree, right? Always 20 degrees centigrade because it's got temperature control.
During time 20 plus or minus 2,
Exactly.
and the room temperature 25 plus or minus 1.
Minus 1 or minus 2?
Minus 2.
Minus 2. Huh?
But is ambient temperature maximum 40.
This also table also showing same.
Why we are doing this curing? What is the purpose? What is the purpose of curing?
The curing is doing here for the durability of concrete, for the strength of concrete. If you will not cure the concrete, the strength will be affected.
It will not get the permanent strength because
Not only cement, but with the chemical
reaction
reaction.
without water.
So if we do curing,
You-
lift the cement will do the chemical reaction to reach maximum strength.
If we do the concreting, there is a moisture inside the concrete.
You will keep it.
If we keep without curing, it will be
Absorb.
Should be.
then the concrete will not get the required strength.
Yeah, that's true.
When we are doing curing, we are not giving something strength from outside. We are just protecting the inside moisture for the
Yeah.
Same. But is sites also need same procedure.
yeah.
But who pouring it? No. Only 2 days curing. After days finishing.
No, this is this is.
Now we have to control.
Outside no curing.
Yeah.
Outside there is a curing compound, right? Curing compound is.
No. They are doing very well. Quality is better. They are doing proper curing, right?
Yeah. So curing is very important for getting.
This is more effective than
Because they make it protected, like the inside moisture is not going out. That's
Yeah. Okay, so this table also showing same that this is in-place concrete, this is lab concrete, and this is a field. So initially, in-place concrete is high, but at the last after 7 days, cube in laboratory is getting high. Yeah? I can proceed. Okay. I'll share with you. Okay, what I told you before that temperature is more means more strength. Huh? This is showing same that maturity. This is called maturity. Concrete maturity will be up if its temperature is high. Temperature is high, and at time passes, more strength. Temperature is more strength. So if you see that it is showing 7 days. So this if you strength and time, initially it is going up, and after 7 days it is almost almost horizontal. That's why we are taking 7 days curing. 7 days curing and 7 days result. Because after 7 days,
normally 28 is better.
Exactly.
Because after 28 days,
You will get
concrete will be-
90%.
Yeah, but 7 days only if we are
Indicative.
achieving 75% of 28 days in 7 days,
Yeah,
then we can say that it's okay.
exactly.
But the
7 days is only indicative.
Initial 7 days.
Full strength,
Actual strength
28
up to
after 28 days.
You will get.
Concrete is named 40-20. 40 means minimum strength of 28 days. Compressive strength to the cell. 40.
Yeah.
And 20 means size of fabricate.
Because it's
Yeah.
internally wet up to 8 days.
Okay, now durability for the rust. Well, concrete there is a reinforcement, and reinforcement is getting rust, right?
Yeah.
What is the reason for getting rust?
Inside
Yeah.
the concrete, what?
Yeah,
Inside the concrete,
yeah.
What is
Yeah. I'll check because
absorption?
First of all, everyone knows what is concrete durability and what is concrete strength.
It's different.
Yeah.
Durability, actually, this is the age of
Concrete,
age of concrete.
age of concrete durability.
Life and the strength itself, the power of concrete.
Like if any concrete structure, if it's it's required one strength, that if this strength will bear this concrete structure. If it increases, it will fail. But up to this strength, it will be safe. This is concrete strength. And concrete durability, for example, one structure is designed for 50 years. And if it withstand for 50 years, it means it's durable.
There's a long
Like-
lasting concrete. Huh?
Yeah.
Long lasting. There's a okay. Long lasting means the less economic. Huh?
Durability will affect from the
Yeah.
outside, like
Okay.
weather.
So if you see the photo, there is a lot of rust. Huh? Okay. So do you know what is the salt we are taking? Cooking salt. What is the can you tell? Yeah. What is the salt actually? Salt. What is the chemical? Sodium. Yeah. Right. Yes. Sodium chloride. Same sodium chloride is available in the sea water. Huh?
Yeah,
And same says sodium chloride is available in the soil.
soil.
That's why ground foundation always with the GGBS, right? SRC or GGBS.
SSP.
SSP.
Actually, the sea we are using under the ground.
Yeah. So this is the reason
Above
because
the ground, okay.
yeah, this is the reason because there is a lot of chloride and sulfate.
resistance,
Sulfate and sea water, especially sea water is carbon dioxide also. That's why to protect the chloride and
To
sulfate,
resist against the this
salt. Yeah.
That's why they
Sulfur,
mentioned
yeah.
SRC sulfide resistant.
durability, all
Exactly.
durability factors.
Yeah, durability factor.
No.
So that's
The
why.
reason for to be as still rust.
Yeah. So it is shown that what is the percentage of, if you see that chloride is 55% in the seawater and the sulfate is 7.7%. That's why the chloride and sulfate is the main reason. These are like a villain, you know, villains, yeah, movie. this is the villain of concrete and steel. Okay. If you see the photo, the sulfate, whenever you start the concrete, for example, Zafriq will start the concrete. Next sulfate attack is chloride attack. Huh? They're the enemy of concrete. If you see the chloride, they're dancing and going to the steel. And after few this it's coming like that. Okay, this also showing same that it is reinforcement steel and how it is passing from the rainwater. It's rain, it's cloud. This is coming and getting rust. Huh? Okay. So rainwater also have chloride. If you see rainwater percentage chloride, what is chloride? Chloride is 7%. Rainwater also. Okay.
Yeah. Chloride is bad for steel or for concrete?
Both problem. Chloride sulfur is the enemy of concrete and steel both. Okay. So hate them. Always we have to hate chloride and sulfate, but we are taking food. We cannot avoid. Only for concrete you can hate. Okay. Okay, this is our discuss source of chloride. Source yeah. We will go first. And this also, okay. This also it is going. Okay. This also if you see that it's going. This also going like that. That means it is showing that more white, and passing the chloride very fast. It is showing chloride very fast if it is more void. That's why fly ash base is for more durable. Yeah. This is showing that for the clear cover. How many? Yeah, Fauzi, what is the clear cover you're using? Yeah,
Wall or
5 centimeter.
wall or base?
For the base,
It's different.
base
7.5, right?
Yeah,
so
so
base
7.5, one 5 something, 3 something.
Okay, so what is the reason actually 7.5? Why 75.5 down and up 5 centimeter? Why not same
This is underground.
underground? But why not 10? Okay, this is actually is coming from this. There is some calculation and chart. So if you use this chart, then anybody, yes. This one is structural, another is environmental. Huh? So for the sea, for example, if you next project you will work in the Dubai port, for example, and there is a big foundation. So they are clear cover maybe 15 centi. So why they are putting 15 centi? Because there is a chloride content is more. And they are thinking they are checking how many days, how many years to reach to the still. Huh? So more depth means it will reach maybe 100 years. Less means maybe 10 years it will reach. Huh? So this is a concept actually.
This one.
Okay. And concrete also.
But not same mix design.
Yeah, no, sorry, different.
Also design is-
And mixed design also we have to select that some mixed design concrete is a chloride is going very fast. Some concrete is very slow. That's why the microsilica is being used to fill the voids. If you fill the voids, they cannot go. Fill the voids means passes actually. Huh? If open passes, everybody can run and go to the steel. That's why microsilica is used to stop.
the way.
The microsilica is the enemy of salt. Okay. Okay, so this is the, it is very short actually because this is wide things. This is the purpose of this to get the basic concept of concrete. Huh? What is its strength, how to strength, what is the chemical responsible for strength, what is the chemical response for durability. So get the idea, but it is huge things. I'll share the presentation. If you have any doubt, it comes to me.
The test.
Durability test,
Six or
Yeah.
eight, I think test for the.
yeah. A test, a specific test I did not input here. It is just concept of the year.
RCP or.
This water permeability, water absorption,
And,
acidity and iron.
This test, year for site specific test will
In the next
take.
topic, actually, you have to
let's-
discuss about this one. You have to prepare the
test.
on the basis of this durability test.
Durability test. Okay.
Because that is also very important. for
Very
us.
important. The next topic I will do it. later.
But anyhow, it's very important, technique which we gain.
Yeah. Okay, thank you very much for attending. So always feel free to discuss with me for any issue. Thank you.
Everyone sign the attendance sheet? Yes.
Thank you, engineer, for your kind of information.
Why gap? Was you signed?
Yes, sir. Okay,
Now three gap. Okay.
What is the solution now? It's a compression strength
Mhm.
failed in 7 days.
Mhm.
And the 20 days, 20 years.
Mhm.
What is the solution?
The solution is that then we should go for two option. Yeah, two
So
option.
what is the solution?
If there is a say, additional sample, cube sample,
No,
sample
no,
is there.
As I mentioned,
So then we can do it. Additional sample if you take, then we can do it. Additional sample. If it is failed, then we can go for non-destructive and
No,
destructive.
then you will check the cube size which prepared, maybe it is wrong.
all the, all right.
Impossible to.
you didn't face any failed
I
tubes?
face, but the cube size was, the mold size was wrong.
Yeah, والله, it's very-
No, but only the year. If this failed, then you have to go for non-destructive or destructive test. You have to take the sample.
There is, the two, the one will be passed for the destructive.
You want to fail the No.
Yeah, I did.
But you didn't face it before, huh? With the